What is the history of ampere, volt, and ohm units? Imagine a world without clear measurements for electricity. It would be chaos trying to build anything electronic. Luckily, these units help us measure and understand electricity precisely. Their stories are tied to the scientists who made sense of invisible forces. The ampere, which measures electric current, is named after André-Marie Ampere, a French physicist from the early 1800s. He discovered how electric currents create magnetic fields, leading to what we call Ampere's force law. Early on, scientists defined the ampere based on the force between two wires carrying current. They used experiments with metal wires and measured the force per unit length. By 1948, the official definition was set. If two infinitely long, parallel wires are 1 meter apart in a vacuum and carry 1 ampere of current, they produce a specific force. This ties the unit to mechanical units like meters, kilograms, and seconds. Today, the definition has shifted to be based on fundamental constants, making measurements even more precise and easier to reproduce everywhere. The volt, which measures electric potential difference or electromotive force, is named after Alessandro Volta. He invented the voltaic pile in the late 1700s, which was the first chemical battery. This invention proved that electric potential could be stored and measured. In the late 1800s, international efforts standardized the volt as a unit. It is defined by the relationship between power, current, and voltage. Early standards used stable electrochemical cells, like the Weston cell, which produced a fixed voltage. Now, modern calibration uses quantum effects like the Josephson effect, which provides extremely accurate voltage standards. These developments help engineers calibrate devices and ensure measurements stay consistent over time. The ohm, the unit of electrical resistance, is named after Georg Simon Ohm. In 1826, he formulated Ohm's law, showing that voltage equals current times resistance. This law explains how voltage, current, and resistance are related in a circuit. Standardizing resistance units took many years. In the 1860s, scientists proposed naming the resistance unit after ohm. Early standards involved physical objects like mercury columns with specific dimensions and temperature controls. By 1881, the ohm was officially adopted as a practical unit. Over time, the definition was refined to match international standards, and today, quantum effects like the quantum Hall effect are used for the most precise resistance measurements. All these stories show how the units we use today evolved from experiments, discoveries, and international efforts. They moved from physical artifacts to definitions based on fundamental constants, making electrical measurement reliable and consistent worldwide. Understanding their history helps us appreciate the precision needed in calibrating test equipment and ensuring our electrical systems work perfectly.